We all know that nowadays blood group information has become an integral part of any personal record. Like the image shown here, this is how blood groups are usually tested in laboratories by observing the clumping or the agglutination pattern. But how does this happen and what is responsible for this? The answer is human RBC antigens. Every individual's RBC has certain proteins which we call as antigens expressed on its surface. So depending upon which antigen is expressed, the blood group of the person is decided. Like for example, if a antigen is expressed on the RBC surface, then the blood group becomes A. In addition, if a RHD antigen is also expressed, then the person's blood group becomes A positive. So now as we know that each one of us can have different antigens expressed on our RBCs and our blood groups can vary. Whenever a blood unit is dispatched for clinical reasons, the blood group between the donor and the recipient is matched. Here we have a typical process of how blood matching occurs in a blood bank. So they start with initially matching the ABO and the RH antigens, and even after that, if the case remains inconclusive, other factors are checked, because any mismatch which occurs between the donor and the recipient blood can lead to adverse hemolytic transfusion reactions. So what are these other factors? What we all are aware of is the difference that is occurring in the ABO and the RH antigens. But in reality, a person's RBC expresses many more antigens that are also equally important in deciding the person's blood group. All these antigens are grouped together based on their genetic cause, and totally we have 43 blood group systems and not just ABO and RH. Like we see in the figure here, we find names like Kell, Duffy, Diago, Cromer. These are also blood groups like ABO and RH. This is one of the best illustrations of how a person's complete blood type will look like. So taking this person, clinically his blood report will be given as A positive because he has the A antigen and he also has the D antigen. But in the real scenario, his RBC expresses multiple other antigens like it is listed here, and this forms the complete blood profile of a person. And if we are able to decipher this complete profile, transfusion complications which are caused by these minor blood group factors can be greatly avoided. So now coming to the point of how rare are these rare blood groups in India. So within the last 4 years, few rare blood groups have been reported in India. So looking at 2018, the P null phenotype was identified by a group of doctors from the Kasturiba Medical College in Karnataka, and this year, a few months back, the rare AEL blood type was reported for the first time in India from Shalby Hospital in Ahmedabad. So, with these new reports coming in, there are initiatives to maintain rare blood donor registries in our nation, and the best example which could be cited here is the Kasturiba Hospital Rare Blood Donor Registry. Such efforts help us to maintain population-specific blood profile records. Thereby, they also help in increasing the rate of transfusion success in our nation. So, on this occasion of World Blood Donor Day, let us be aware of the rare.